Hi everybody, my name is Gary Euler and I'll be walking you through this overview of operations presentation today. Let me tell you a little bit about myself. I have basically spent my career in the operations environment. I spent the first half of my career with the Federal Highway Administration. I dealt with issues like traffic simulation models, signal timing optimization, traffic control systems. Eventually, as all that evolved into ITS and Transportation Systems Management and Operations, I dealt with that. I was the Deputy Director of the ITS Joint Program Office prior to leaving government in about 1996. I spent the second half of my career working for various consulting companies, did some business development, and also consulted on a variety of assignments, including as the program manager on the consulting side for the I-95 Corridor Coalition. So a long career in this business. These are the subjects we're going to be talking about as we go through the course today. You can look at these, or when you go back online to view the slides, you can take a more careful look through them. It's very much an introductory course. No one will leave this course as a technical expert necessarily. But what we try to accomplish through this course is to define a lot of different terms so that you become familiar with those terms. We talk about why TSM&O is important. We give you a little bit of depth as to what it is. And I think just as importantly, we talk about a number of things that are needed to support doing TSM&O. You'll see this agenda slide repeated throughout the course. We use it as a placeholder as we transition from one subject to the next. And as you see on this slide, as we come to each subject, we bold the transition, what we're going to be talking to. So the first subject is to give you a little better idea when we say TSM&O what it is, and to compare and contrast that with intelligent transportation systems, with ITS. This is a definition of TSM&O, comes from the Institute of Transportation Engineers, as you can see on the slide. I'd like to focus on three terms in that definition. The first term I'd like to focus on is performance, the word performance. When we deal with TSM&O, the essence of it is to look at whatever demand and capacity characteristics are out there on the transportation system and try to make the best of those circumstances. So it's really about getting the system to perform as well as it can given the circumstances. So a heavy emphasis on performance. The second word I'd like to focus on is the word program. We have done what we'll be calling TSM&O, or what we do call TSM&O. We've done it for a lot of years. We've called it traffic engineering. We've called it traffic operations. We've called it transportation systems management, TSM, for those that have been around for a while. It's all the same stuff, but yet what we're trying to emphasize now with the framing as TSM&O, Transportation Systems Management and Operations, is doing it as a program, doing it in a way that's planned, doing it in a way that's supported with budget, supported with people, supported with processes throughout the organization. So the term and program is very important. And the final thing I want to focus on is the phrase systems, services, and projects, which really gets at what when we say program, what we mean. It includes the systems that we use, the services that are provided through those systems and through other means, and the projects that comprise installing, managing those systems and services. So all of that is, when we say TSM&O, all of that comprises it. On the other hand, when we talk about intelligent transportation systems, we're really talking about a component, if you will, of TSM&O. So ITS, Intelligent Transportation Systems, are really the technology and the systems that are used in TSM&O to accomplish all these good things that we're trying to do for the traveling public. So the technology is typically surveillance, it's communications, it's the data processing, it's the display, the dissemination of information, all of those technologies that comprise systems that constitute intelligent transportation systems. So you get the distinction. We'll talk a little bit more about that in a couple of slides. TSM&O itself is pretty complex when you dig into it, when you get beyond the initial definition and really think about what it is and how these things interact with each other. When we think about TSM&O, we typically think about reducing congestion. We maybe also think a bit about safety and the impact of what we're doing on safety. As the first bullet says, those two things are not independent. They very much relate to each other. So for example, if where there's an incident on the road, if as part of our TSM&O program, we can get out there and clear that incident quicker, we're reducing congestion certainly, but we're also probably saving some secondary accidents, which is a safety issue. So the two things very much relate. Strategies can be mutually supportive, or they can maybe work against each other a little bit. So as an example, we can look at agencies that do ramp metering that maybe also use the shoulder to increase the capacity along the freeway. We're managing the demand on the one hand, we're providing additional capacity on the other. Those things support each other. We can think of another example where we might be providing priority for transit vehicles. So we're improving a trip along an arterial street for a bus, be able to adhere to schedule better, get there a little quicker, but perhaps at the expense of other traffic, especially traffic on the side street. So sometimes things don't necessarily mutually support everything that we'd like to try to accomplish. And that example a little bit, but if we think about something like diversion, we may be in a situation where we may be improving the traffic flow along a freeway by diverting traffic off of the freeway, perhaps when there's an incident. But that traffic has to go someplace, and so it'll likely go on a parallel arterial street and increase the demand on that arterial street and have a negative impact on that facility. So it really is a complicated subject that does require a lot of forethought as to what it is that you're doing and how it is that you're accomplishing things. TSM&O will a lot of emphasis in this course on TSM&O, as I said, as a program, and how it relates as a program to all the other functions of a transportation agency. Transportation agencies have been around for 100 or more years, and they came into existence obviously as the emergence of the automobile happened in history, the provision of the roads and the facilities that had to serve that automobile traffic. But as we all know, that built infrastructure is pretty much in place. We're still building some new facilities, we're still doing some widenings and those kinds of things, but a much increased emphasis on better managing, optimally managing, if you will, whatever capacity is out there, whatever facilities are out there. And that's where TSM&O really comes into play. It's that operation, it's that service that you're providing to the public that is the hallmark of TSM&O. As I said, TSM&O has been called any number of things throughout time. I won't deal with this slide a whole lot. More recently, there have been movements to call it operations and management, or sometimes you see those reversed. There was a movement to call it management and operations, M&O. Whatever name we call it, I think the important thing to remember, and the TSM&O, I should add, is the thing that apparently is sticking these days from the national agencies that manage these types of programs. But I think the important thing is to remember that really what TSM&O adds is a programmatic element. And that's really what the emphasis is and why this new name has come into existence. TSM&O is, even within TSM&O, if we can get by the name and the acronym TSM&O, which doesn't exactly roll off the tongue, but even if we get through that, even within TSM&O, there's a set of acronyms on their own that can be confusing, especially to those outside. And we'll talk about some of these throughout the course, but we can throw out things like ATM and ATDM and ICM and the NOCOE and get really lost in an alphabet soup of terms. And we'll be going through some of those terms. I think the important thing to remember is that internally we can communicate with each other using those terms, but the public doesn't necessarily understand, or the decision makers don't necessarily understand what those things are. It's important to speak English when we talk to them. This chart contrasts, really kind of summarizes a lot of what we've already said about ITS and TSM&O. You'll see as you go down through the ITS column that ITS is supportive of TSM&O. You'll see the representative elements are really system-oriented, and you'll see that the skills are very much technology-based, the surveillance, the communications, and those kinds of things. If you look at the TSM&O column, you'll see the purpose is to really achieve the benefits, the transportation system efficiency. You'll see the elements are broad, not only comprised of ITS elements, but also a management component. So we get into processes, procedures, policies, those kinds of things. And the skills are more typical of the skills that are present in most transportation agencies dealing with transportation planning and engineering. So a much broader subject, whereas ITS is very much more technical focused. So that's the first part. We're going to shift gears a little bit now and maybe even go a little more broader and to talk about the relationship between TSM&O and the overall transportation system, which begins to be depicted on this slide. This slide really talks about depicts in a kind of a very broad way the relationship between the network infrastructure on the left, the management and operations on the right, the plans, processes, and policies that lie in between and relate the two things to each other. But the two things I really want to focus on more from this slide are that top box, which is performance management, and the bottom box on the right, which is talking about organizational capacity. And in fact, we'll go right into the organizational capacity next. So when we talk about organizational capacity, this is what we're talking about. We're talking about structure. How is TSM&O dealt with as part of the overall DOT organization? We're talking about internal partnerships. We could talk about external partnerships as well, but internal to the agency, we're talking about internal partnerships. How does the TSM&O elements relate to all the other DOT units? And is it integrated into the activities of those units? We talk about resources. How are resources acquired to support TSM&O? Is it a line item in a budget someplace, or does it have to beg and plead for funding from a variety of sources? And we'll also talk a little bit about workforce development. Are policies in place to not only attract the right kind of people to accomplish what it is that you need to do, but can you keep them, and are there career advancement opportunities so you can keep these kinds of people? So let's deal with the structural aspect first. This is kind of an idealized state DOT organization, idealized from a TSM&O perspective at least, where it depicts TSM&O at the second level of the organization and at the same level as some of the more traditional functions, such as planning, design, maintenance, the districts, and so forth. I call it an idealized structure because I don't believe there's any structure just like this anywhere, in large part because when you put all those people at the same second level, that then becomes a lot of people reporting to that CAO up at the top. So it's not typically practical that you'll see an organizational structure this way. We show it to basically convey the notion that what we're talking about when we talk about TSM&O as a program is to give it the same visibility, the same structure, if you will, as these other DOT functions. The second alternative is more typical. In fact, this is somewhat simplified version of an org chart from the Maryland State Highway Administration. And on this one, you'll see that it's a third level activity within the organizational structure. You'll see a chief engineer over on the left of the diagram. You'll see a chief engineer for maintenance and operations on the right side of the diagram. And underneath that individual, you would see the functions that would comprise the TSM&O. The freeway operations and the traffic engineering and safety split differently, but still reporting up through the same channel. This is more typical. Maryland has the advantage of being a relatively small state. They tend to do a lot of things from the central headquarters office, and so this organization works in their environment. A even maybe more typical organization chart might look something like this, which is similar to what we just saw in Maryland, except that you'll note that the TMCs have now been moved under the districts. And that is very typical, especially in states where you have larger urban areas with a lot of rural in between. So you'll see the TMCs within the districts. You'll see some kind of a headquarters function dealing with the ITS, the traffic engineering and safety, the TSM&O elements, if you will, more from a policy and to ensure consistency of practice and those kinds of things. This is good and bad. The notion of having the TMCs local has some obvious advantages in terms of actually being local, managing the situation locally, but can lead to divergence in practice in terms of what's going on throughout the state. So good and bad. The important point, and I think what we're trying to get across, is that the structure, whatever the structure is, does influence the TSM&O priority within the department. And so when we say that, the kind of questions that we pose is there some point of responsibility within the organization for TSM&O activities, or is it diffuse and spread out, so essentially there is no overall responsibility? How many levels of reporting exist between where TSM&O is dealt with and the top of the organization? And this is an issue that really relates back to the ability of TSM&O to compete for resources within the DOT. The lower level, the harder it becomes to compete for those resources. Is there a TSM&O line item budget someplace that covers at least a lot of what goes on within the TSM&O program? And is there accountability? Is there something that is reporting on annual TSM&O activities, maybe how much money was spent, maybe what was accomplished, benefits to motorists? Is it visible? Is there something that talks about TSM&O? All of that reflects on the position of TSM&O within an organization. For the last, I'll say 5 years or so, a number of us have been conducting workshops across the country that the essence of them is to get in with a number of people from state DOTs and their partner organizations, and to have them do a self-assessment as to how TSM&O is being dealt with as part of their state DOTs, or in some cases as part of a region. And really not to look at it from the standpoint of reviewing technology and those kinds of things, but to be talking about some of these processes, ability to get budget, processes in place to plan for what you're doing in TSM&O, how you're dealing with your workforce issues and those kinds of things. A couple things that typically pop up, not all the time, but quite frequently, that really get at this slide, have to do with involvement of TSM&O personnel as part of the project development process. Too often we hear of state DOT or TSM&O people within state DOTs where those kinds of considerations become an afterthought. We're building a new facility. We don't involve the TSM&O people up front. And so some of the things that you might be able to do in terms of providing for communications, or in terms of providing for the appropriate traffic control devices, or even better managing the traffic during the construction period, aren't reflected as well as they perhaps ought to be, if the TSM&O people were involved. Another deals with TSM&O involvement in the transportation planning process. It is difficult, obviously, to take a look at an operational issue and try to compare it with a new facility or a widening. But yet, in order to get the resources for TSM&O, the available budgets, the TSM&O aspects have to be considered as part of that same process that allocates the funding for the various projects. And that has not always happened either. So it is important. I say that as two examples of importance of building relationships between the TSM&O units and the other activities within the department, as illustrated on this next slide, that essentially tells a story that the TSM&O or the operations essentially interacts with everything. We've talked about planning, we've talked about design. I think construction is evident from the standpoint of managing traffic through work zone areas or construction areas, or even making people aware that the construction areas are out there so they can better plan their trips at time of day or to avoid those construction areas. Maintenance, I think, is also fairly evident. If you're going to put ITS assets out there to do better TSM&O, then those things have to be maintained, just like bridges and pavements and other physical assets. And that isn't the only thing that TSM&O relates to. Those are the main functions within a department. But there's a lot of other things that the departments do that TSM&O does relate to. Those things include things like performance management, asset management that we just talked about a little bit as part of a maintenance function, risk management in terms of looking at projects, looking at planned activities and the risk associated with those. We will be talking more about workforce development in a few slides, and towards the end of the presentation we'll spend some time talking about customer service and customer service orientation within the department, which is critical not only to TSM&O but throughout the department. So as you think about TSM&O, you may feel like you're on an island, but you're not. And the more you're integrated into the fabric of the organization, and the organization recognizes you as part of that fabric, the stronger program that you have, the better program that you have. This is basically another depiction of essentially the same point. Shows management and operation cutting across activities of the organization, from planning through design and construction all the way through maintenance. So another way of looking at it. Another important aspect of TSM&O that I think tends to get overlooked sometimes is that a typical project might relate to an intersection. It might relate to a link, a travel link, if you will, or a segment of a road. But you don't necessarily go in and rebuild all the infrastructure within an urban area. On the other hand, when you deal with TSM&O, you can make just single intersection improvements, but more typically you're dealing with at least a corridor, if not a complete area. So the impact of TSM&O is much broader. It's not necessarily as local as a typical traditional construction project, but can be much broader and as broad as urban area or even statewide in some cases. So something as a sales point to consider. But yet when we look at the funding allocation for TSM&O, we find that it's relatively low. It's difficult to count, for one thing, because TSM&O has not been a separable, typically not been a separable line item budget in a state DOT. There's not one place you can go to get this information. TSM&O elements, ITS elements tend to get buried in construction projects. It's often difficult to find out how much of the investment in a typical project is for these ITS elements as opposed to something else. So it's hard to get a number. But the numbers that have been reported by people, including the U.S. Senate, who have asked these types of questions, is that the share of resources devoted to TSM&O have typically been in the low single digits. So somewhere, upwards of 2% to 5%, something in that kind of range. And the conversation becomes very difficult, as you all know, when you're talking about it in a time of constrained resources. So study after study points to the need for revitalized infrastructure, transportation infrastructure in the U.S. We all feel the pressures to do a better job of managing and operating the facilities are out there through TSM&O, but we're all talking about a small pie. And so probably the solution doesn't lie in arguing with each other about what our share of the pie is vis-a-vis somebody else, but probably really more realistically or more fruitfully lies in doing what we can to help try to grow the pie so that we all have better resources or more resources to do better jobs as we'd all like to do. We're shifting now to talk a little bit about the workforce side and trying to illustrate some of the differences between the types of skills needed for TSM&O as opposed to the traditional kinds of people that have peopled our transportation agency. And I'll be quick to say that I start this conversation as a typical person who started my education was as a civil engineer. I suspect most of the people that will be viewing this video come from a civil engineering type background. That is still the typical degree through which our transportation agencies are staffed. But if we think about the kind of things that TSM&O, or more specifically ITS, require, if we talk about surveillance, if we talk about communications, if we talk about IT and data processing and those kinds of things, then we're really talking about things that aren't necessarily covered very well as part of a civil engineering curriculum. So you think about electrical engineering, you think about computer science, you think about operations research and those kind of degrees. Involvement on the professional side doesn't necessarily take you to ASCE, although there's certainly nothing wrong with that. But it takes you to organizations like IEEE, ITS America, or the Institute of Transportation Engineers. And you can go on through this assignment. As the workshops that I referred to earlier, the workforce development is always pops up as an issue. And among the things that we talk about are our ability to recruit from these non-traditional disciplines. It's having, in some cases, it's just a simple matter of having the position descriptions that are available to accommodate somebody that isn't a civil engineer. The career advancement becomes an issue. So there's lots of things that relate to this that agencies need to be thinking about, and in some cases at least need to do a better job of accommodating the right kind of people necessary to do TSM&O and ITS in a good way. We're going to dive some more into terminology, but in this case we're going to do it in a couple different ways. We're going to talk about some of the organizational acronyms, that alphabet soup, and then dive a little more into some of the other more technical, if you will, terminology within TSM&O. These are some of the organizations. I think a lot of you are probably already familiar with a number of these organizations. I'm not going to talk about each of these individually, but we will spend a little bit of time talking about AASHTO, the American Association of State Highway and Transportation Officials. And if you're not aware of it, I want to introduce you to the last organization on that list, the National Operations Center of Excellence, which I think it's important for all of you to be aware of. AASHTO is, of course, the organization of state DOTs. Just like our transportation agencies, for a long time, AASHTO very strongly dealt with the more traditional things that transportation agencies do, geometric design standards and bridge design and pavement and all those good civil engineering kind of things. There's a whole body of standards that have been developed through AASHTO that govern how state DOTs operate, built up over the 100 years that the state DOTs have been in existence. So we do those things well. There's a lot of history, a lot of experience that goes into it. It's very mature, it's very established. More recently, AASHTO has in a major way gotten involved in the system management and operations area. There is a subcommittee within the Standing Committee on Highways called the System Management and Operation Committee. And a number, practically I would guess the majority or a large number of the states, if not all, have membership on the System Management and Operation Committees. These people meet periodically, they exchange information on good practice. They're heavily involved in the development of the standards that will support good system management and operation. The comparison, I think, is that while a lot of what we're doing in design and bridges and so forth is very much in its adulthood, what we're doing in system management and operation is probably in its teenage years at this point. So a lot of good stuff happening, a long way to go to bring it up to the same level as what AASHTO has traditionally done. To support that, there is more recently in the last year or so been the formation of the National Operations Center of Excellence. It's in some respects, I guess, can be described as kind of a virtual organization. There's only a couple of people on staff, so they're very much managers of information. It was formed as a partnership of AASHTO, the Institute of Transportation Engineers, and ITS America, with some financial support from the Federal Highway Administration and the USDOT. And you can see what on the slide, the kinds of things that the National Operations Center of Excellence does. Peer exchanges in terms of best practices are facilitated. Product support, especially emerging from recent research programs in the area. Training and capacity building, practice area forums within TSM&O. And I think importantly, a knowledge center, which is essentially an online library full of sources, resources, reports, or pointers to where you can find reports. If you haven't, I would encourage you to go on to the website listed there and explore a little bit and see the resources that are available. It's going to be a good source of information and maybe save you a little frustration in terms of just going through Google and trying to find things that way. Other key national players, I think probably all of you are aware of the U.S. Department of Transportation, in particular the Federal Highway Administration through its operations office. If you go on to their website and find the operations page within the Federal Highway website, there's a whole lot of resources, reports, and so forth available through there. Most of which would also be available through the Operations Center of Excellence, but still a good resource. And from more of a research perspective, the Transportation Research Board has a lead role in transportation research related not only to TSM&O, but everything that goes on in both the highway and transit, as well as other modes of transportation, and is a good source. More specifically, recently, and I'll just spend a little bit of time on this, there was something called the Strategic Highway Research Program. It was funded by Congress. It looked at 4 critical areas identified by the states as being critical to their current operations, one of which was called reliability. And the reliability, as we'll see as we go further in the presentation, really dealt with the kinds of things we're talking about when we talk about TSM&O. And we'll be talking about a variety of products that emerged from that research as we go through the remainder of the presentation. So let's move on from the organizational alphabet soup and get into some other things related to more of an analysis kind of orientation. We'll talk about more specifically about the Highway Capacity Manual and level of service a little bit, because I'm going to tie that back when we get into it to the discussion we started earlier about the non-recurring congestion and how we've dealt, or maybe more appropriately not dealt with, the non-recurring congestion as we've made our plans. I'm sure all of you are familiar with benefit cost analysis and what it is, and have had some experience with it in a variety of ways. The Highway Capacity Manual is something that's been out there for a long time. It's a TRB publication. It continues to be supported with a lot of national resources. And basically it's a set of procedures which over time have become computerized that deal with, as it says, concepts, guidelines for calculating not only the capacity of a facility, but also the quality of service given the demand on that facility, and we'll come back to that. One of the ways that quality of service is measured is through this thing called level of service. And level of service is essentially a grade, A being essentially free flow conditions, F being conditions that are saturated, and the grade letters in between lead up to that F grade. There's some issues with level of service that we'll get to in just a minute. I want to also talk about these terms, but I want to, the next slide really illustrates it better, so I'll talk more specifically about these definitions when I get to the next slide. But what this really touches on is through the SHARP 2 research program, one of the areas that was identified by the state DOTs as being important was this area called reliability. And if you think about what that word means in plain English is something that is reliable is something that happens all the time. You can count on it happening. If you think about a trip, a typical trip that you make, it might be your commute, might be some other trip. But if you think about your commute and you think about a reliable commute trip is one that would occur in roughly the same amount of time every day. You can plan on it. It's going to be 30 minutes or whatever it is. It may vary a little bit around those 30 minutes, but it's pretty reliable. If you're in a situation where it's 30 minutes one day and 45 minutes the next and an hour the day after that, then you don't have a very reliable trip. And there are reasons that that's probably occurring, and it probably relates back to incidents and those kinds of things. But the notion of reliability has emerged from that SHARP 2 research as being very important, and especially being critical as a need related to TSM&O kinds of solutions. So this is in fact illustrated a little bit on these diagrams. The probability density function basically shows the probability that travel time, if you look at travel time as being plotted on the x-axis, it shows the probability of travel time being close to some mean. So that big parabola in the middle that's pretty narrow, that basically says that the probability is pretty high that it's going to be that value, and that's a pretty reliable trip. If you look at the purple parabola that's spread out, that says that the data is all over the place, and it's not terribly a reliable trip. If you look at the cumulative distribution function, that basically looks at the probability that a value is going to be less than or equal to the mean of that data. So if you look at the lines, in the colors, if you can see the colors are the same from the top diagram to the bottom. So if you look at the lines that are more vertical, that represents a more reliable trip. If you look at the lines that are more slanted, going from left to right, that represents trips that are not so reliable. And you'll see as we get to those slides that especially the latter, the cumulative distribution function is an important issue that's been looked at through some of the SHARP 2 research, including this first study that we'll just briefly mention. Again, I would urge you on any of these subjects that you'd like to dig into to do that. And you can do that typically through the National Operations Center of Excellence, which would at least contain a pointer to the research reports for these things. All of the SHARP 2 projects have the letter designation and a number designation. The L stands for something, I'm not sure what, and the numbers were just consecutively numbered, so there's no real great hidden meaning behind these things. This one had the designation LO2, and it basically deals with all the issues associated with establishing programs for monitoring travel time reliability and plotting those diagrams that we just saw and seeing how reliable your transportation system is. So again, if you want to dig into that, excellent resource. So again, we're still defining things, but now we're going to maybe broaden back out a little bit and take a look at things like mobility, the definition of mobility and how it pertains to agencies and users, and then get into some of the discussion that I've been alluding to all along here related to recurrent and non-recurrent conditions. Mobility is basically the, as you'll see on the slide, it's the ease that people and goods can move from an origin to a destination. We contrast that with accessibility. Accessibility is a broader term. Mobility is part of accessibility. But accessibility relates to basically being able to reach your ultimate destination. So it might deal with things like parking. It might deal with things like the affordability of the trip. Might deal with things like accessibility to transportation for the elderly and poor served and those kinds of issues. We tend to deal with mobility. But I think as the third bullet on the slide says, it is important, obviously, as agencies to deal with the entirety of the trip and worry about accessibility. That said, we're going to focus mostly on mobility in this presentation. Congestion is essentially the inverse of mobility. I think we all know what congestion is. I think we all probably understand it at some level that no matter whether you live in Washington, D.C. or Washington, Pennsylvania, you think you have congestion, you have a congestion problem. Of course, the two things aren't comparable at all, but to the people that experience those trips in Washington, PA, where they are delayed, it's an important issue to them. So everybody has to deal with congestion at some level. What we'll deal with in the upcoming slides is the various definitions of congestion, how it's measured. And let's start by putting on the table what we've talked about up to this point, which is the recurring congestion and the non-recurring congestion. Recurring congestion is that which occurs, just as the names imply. The recurring congestion is that which occurs every day. So it's out there. On your commutes, you typically think about it in terms of commuting, but it could even be a Saturday afternoon around a shopping mall someplace. It's there. The demand is going to be there. You have so much capacity. It's predictable. It happens practically all the time. So that's recurring delay. The non-recurring delay is something that you can't predict. It's something that's unexpected. And so when we look at the next slide and we look at what the causes of delay are, if you look at that slide, you see the definition of bottlenecks. You see the poor signal timing, which is presumably out there all the time. Those are the things that comprise predictable delay, but the traffic incidents, the bad weather, the work zones, the special events, are things that aren't out there all the time, are things that happen. They happen frequently, but they don't necessarily happen all the time. And they actually add up to more than the delays that are out there all the time, the recurring delays. Now you'll see different pie charts and you'll see different numbers, and I'm sure there's a variability depending upon where you are in the country, large urban areas, small urban areas, those kinds of things. But nevertheless, the general point is true, and I can attest from personal experience that the longest delay I ever had was on the Pennsylvania Turnpike. It was in a very rural area, Donegal, Pennsylvania, if anybody's ever been through there. It turned out to be a tanker overturned. I got caught in a queue. I turned on my radio to listen to the beginning of a baseball game. When the queue started back up again, the last out had just been made. So I sat there for about 3 hours in that queue. Now that was years ago, and I'm sure they would clear I'm real sure they would clear the incident quicker today, and the delay wouldn't be as long. But it just illustrates the point that these non-expected delays don't necessarily just occur in urban areas. They can occur anywhere, and people can experience these kinds of delays anywhere. So why is it important? I think, probably preaching to the choir to the people that will be viewing this presentation. But increasingly, the state of the transportation system is being identified through measures of congestion. It's elections, local elections sometimes turn on the issue of congestion and what people are proposing to do about it. It's reported increasingly up through state DOTs, and there will be increasing accountability to those receiving federal aid, the states receiving federal aid, up to the federal government and to the U.S. Congress. But congestion, at least as it's been traditionally measured, is not necessarily a good way to deal with the non-recurrent aspect of it, and we'll illustrate that in just a few more slides. This basically illustrates just the general nature of the problem, and again, I suspect you've seen something like this or at least have had discussions about it. But the steep curve, the one going up from left to right on the diagonal, basically represents the increase in demand. The flatter curve, pretty much a straight line going from left to right, represents the capacity that's out there and or that's been made available. And so obviously when you're dealing with a situation where the demand is increasing at that slope, whereas the capacity is increasing at that much lower slope, you're going to have a problem. And that's exactly what we're experiencing today. We talked about the definition of level of service a little bit earlier. Those, again, you can read through that. You're probably already somewhat familiar with these terms, but basically runs from A to F, from free-flowing to what's called irregular flow, or roadways operating under congested conditions. This is a neat shorthand. It's understandable. Everybody's gone to school, so everybody knows when you get an A, that's good. If you get an E or an F, that's not so good. So it tells a story to the public, but yet there are some issues with it, which we'll talk about. This comes right from the Highway Capacity Manual, and so you see level of service is defined through 3 parameters, through density, which is essentially the number of vehicles per unit space, through speed, and also through volume to capacity ratio, which is, as it says, the volume of the demand volume compared to the capacity of a facility. And those numbers are right from the Highway Capacity Manual. So those are the standards that judge whether something is A or E. Now, the one problem that you'll see right off the bat is if, for example, your speed, you measure your speed at, say, 69, is that B or C? So you always have to extrapolate in some way, shape, or form where you have values between. But there are also occasions, and this is real data taken from a freeway facility, from an actual facility. You'll see in the bottom, you look at the speed, you look at the volume to capacity ratio, and they sync up. That's going to be basically somewhere between C and D. But in the morning, if you look at the morning data and go back and compare it to these standards that came from the Highway Capacity Manual, you'll see that you could conclude that the level of service is D or E if you looked at the speed data, or you could conclude that it's C or D if you looked at the volume to capacity ratio. So these little inconsistencies that crop up when you're looking at level of service. The real issue, though, with level of service is that level of service essentially measures performance based on the demand that's predictable. So it really looks at level of service for the recurring congestion aspect. It hasn't looked at what level of service, how to measure level of service, if you will, taking into account all the things that we showed on those pie charts, the weather situations, the accidents, the incidents that occur, special events and so forth. And as we showed you on that pie chart, when that's contributing to over half of the delay, then there are some serious shortcomings in how we're measuring and reporting and dealing with congestion if we're just looking at level of service as it's been traditionally defined. That was recognized as part of the SHARP 2 program. There's a report that has emerged from that SHARP 2 program that looks at incorporating non-recurrent congestion factors into the highway capacity manual methods. You can basically do that through use of like national average data, or you can input local data if you have that kind of data available. And there's recommendations about how to do that, although forewarning, they can be a little data intensive and time consuming. But a major step forward in terms of how we're dealing with talking about congestion and reflecting the true nature of it. Perhaps better ways to think about congestion relates to some other measures of effectiveness. Things like travel time, like the reliability concept that I talked about earlier, like measuring hours of delay. And in fact, there was another research report as part of the NCHRP 20-7 report that came out. You see the title of a guide to benchmarking operations performance measures. The major product of, if you will, of that research is this list of measures of effectiveness that were identified through the research and through the guidance of a committee of state DOT people that deal with the TSM&O issue. So you'll see the title, A Few Good Performance Measures, looking at how to better measure performance. And we'll talk about each of these one by one for a little bit. The first one is customer satisfaction. And this one I think is particularly important to know how the users of the facility, how your customers are thinking about what it is that you're doing and the service that's being provided. Typically, when you think about doing customer satisfaction, you think about doing surveys, but there's lots of different ways to do it. There's focus groups. There's dealing with businesses along a corridor. There's dealing with travel organizations or citizen groups, and lots of different ways to get feedback to measure customer satisfaction. But it is an important one, I think a very critical one. There's two dimensions, if you will, of looking at how you measure the extent of congestion. One of these deals with the spatial aspect of it, how far back congestion is extending on a facility. That may have some importance, especially, for example, if you're looking at it on an arterial, you have a short block. You don't want to back up into the upstream intersection and cause even more problems. So the spatial aspect of it is important. If you're doing ramp metering, you don't necessarily want to back it up onto the arterial street. If you're looking at an exit ramp, you don't want to back that queue up onto the freeway. So the extent of congestion is an important measure. But the timing, the time that you have congestion, the length, if you will, of that congestion is also important. So looking at the length of time that congestion exists on some roadways is another aspect of it. If you're looking at non-recurring congestion, looking at incidents and your ability to shorten the time that incidents are impacted or that incidents are impacting the performance of the system is important. It's also, I think, important to point out that when you deal with this particular measure, performance measure, it's very important to be careful how you define what it is that you're measuring. This talks about the elapsed time from the notification until all the response vehicles have left. That's one way to look at it. Another way to look at it would be to measure it from the notification until conditions are returned to normal. Some may argue that's a better way to look at it, but then you get into the debate about, well, what's normal? And what's normal depends on what time of day, what the normal traffic conditions are, and when you have attained those normal traffic conditions. So important to be very careful how you define that. Delay is obviously important to look at, but we would argue that it's important to look at the two components of delay. So looking at both the recurrent delay and the non-recurrent delay, and looking at those two different components becomes important, in part because, as we'll see later, the strategies that you would use to address non-recurrent versus recurrent delay are separable. You would look at a different set of TSM&O strategies to address non-recurrent than to address the recurrent delay, so it is important to look at both aspects of it. Speed is important. We have traditionally looked at speed through point detection of some sort. When we do that, we're looking at something what we call point mean speed, or maybe you've heard it referred to as space mean speed. We're basically looking at, as a vehicle passes that point, what's the average speed of all the vehicles that pass that point over some period of time. There's something else called the time mean speed, which has now become more measurable as a result of things like the Bluetooth technology, toll tag data, crowdsourcing, which is look at some stretch of road, look at the speed of all the vehicles traveling on that stretch of road at a given point in time, and looking at that average. So it gives you a different way of looking at what speed is. Both are useful. Both are now measurable. Throughput is important. It's one thing to count the number of vehicles, which is you'll see on that slide, but probably more important from a TSM&O perspective, because probably throughout our careers at some point we've all issued the words that transportation is about moving people and goods. And so looking at throughput from a person aspect we think is really important, and it also brings into play some of the things referred to on the slide, dealing with transit strategies, thinking about pedestrians, thinking about bicyclists, and those kinds of things. Probably most of the people viewing this are going to be highway people. We don't necessarily automatically jump to thinking about the transit strategies, but having a performance measure that leads us to that is important. Vehicle throughput, obviously important and very traditional. Travel time is important, but we're going to think about travel time in two different ways. One of the ways we're going to think about it is looking at the travel time on a link, especially if our improvement is going to be focused on a travel link. So what's the average travel time? But perhaps more interesting is we're going to look at a couple of different ways of thinking about travel time. One of these is something we talked about, the reliability aspect of it, defined reliability. One way to measure that is something called the buffer index. Now, we all deal with the buffer index every time we plan a trip. And essentially, if we know that, and let's just use our commute trips from home to work as an example, if we know that takes a half an hour when there's no traffic or little traffic on the road, but yet we know that in a typical morning it might take 40 minutes, but we know that increasingly there are fewer and fewer typical mornings, so some days it might take 40, some days it might take 50, some days it might take an hour. We do a mental calculation as to how much time we have to allow for that commuting trip to get to work on time most of the time. And so that amount of buffer time that we provide over and above that 40-minute average, and comparing that to that average, is essentially the buffer index. It's how much time extra time you have to plan to make that trip reliable for you, given the circumstances. So higher the buffer index, less reliable a trip is. Another way to think about travel time that we don't necessarily think about is a travel time for a trip. So we'll look at travel times on a link, we'll look at travel times on a facility, but travelers experience more than that. They experience travel time from home to their destination, or from work to home, or home to shopping, or whatever. So taking a look at travel times associated with trips is important, and it's especially important for commercial vehicles and people that make trips to deliver from ports to wherever the destination of those goods are. They want to know how long the trip is going to be, and it becomes important in that context. Adage, what gets measured gets done. It's very true, and again, part of this whole notion of making TSM&O a program emphasized with emphasis on performance. We talked about this already, the SHARP project of LO2, basically just another reminder that it's out there and deals with a lot of the issues about how to go back and look at developing a program to help you look at some of these measures of performance and to do it on a continuing basis. So now that we've gone through all the various terminologies and things that we want to go through, let's get into the strategies a little bit and think about what are some of these TSM&O strategies that can help us achieve these performance objectives. I think we all know that there's a broad range of strategies available. Typically, you don't look at implementing one strategy. You might look at implementing strategies that support each other in combination with each other. And again, the diversion from a freeway to an arterial is probably the most easiest way to think about that. You may do some things on your freeway, putting detection out there to detect incidents. You may think about putting some variable message signs out there to inform motorists, to tell them to divert in advance of reaching the incident. You might even put some signs out there to reduce the speed of traffic approaching the backed up queue from the incident. And then as you think about diverting traffic, you might think about doing something with the signal timing along the arterial to flush out the demand, the extra demand that you're putting on the arterial. So all those things are typical combinations of things that you would do to solve a given problem. I think it's important, and we'll talk about this a little bit, to think about selecting the right strategy for whatever it is that your situation demands. And not unlike how we've all been trained in terms of transportation planning or systems engineering or whatever other similar process, the right way to think about it is to start by thinking about what it is that the problem is, what your goal is and objectives are in terms of solving that problem, and then fitting the correct strategy to address those situations. This is a chart that at least at a fairly simplistic level begins to think about that. So again, you'll see the two columns deal with recurring and non-recurring situations. The recurring deals with issues essentially where you have demand that your capacity can't handle. So you're really worried about travel time and delay, and you think of things like perhaps looking at high occupancy vehicle lanes to get more people in fewer vehicles. You might think of doing some management things related to ramp metering to try to keep the freeway flowing a little better. Those kinds of things that deal with that recurring element. On the other hand, if your problem is more on the non-recurring side, the causes might relate to incidents, might relate to weather, those kinds of things. Then your performance measures really deal with how well you're managing those situations, how quickly you're clearing incidents and restoring conditions. You're looking at that reliability measure that we've discussed. And your strategies deal with clearing the incidents, better managing traffic during the incidents, informing people of the existence of the incident so they can make better travel decisions, and maybe even looking at things like responsive signal operation to deal with those kinds of situations. So again, the larger picture is this notion of aligning the strategy with the problem and with your goals and objectives. There's a series of slides you'll see in the presentation that deal with these TSM&O strategies. I'm going to go through these fairly quickly. You'll see a chart like the one shown here that deals with the characteristics, the applicability, and so forth. I won't go over those charts during this presentation, but again, if you'd like to explore those things, the slides are available online. Traffic signal systems, again, nothing new here. It's something that has been in existence ever since there have been traffic signals. I think the ITS element of it that gets added is a degree of responsiveness of those signal systems, and more, I guess, more modern, if you will, is the notion of adaptive systems that constantly adapt depending upon the traffic conditions that are actually measured. And we're seeing increasing use of those kinds of systems in practice. Ramp metering, similar kind of a story. Ramp metering's been around since probably the earliest research was way back in the 60s, certainly in the 70s. We saw some ramp metering. But again, the modern element of it, if you will, is the adaptability of the ramp metering and either increasing or decreasing the metering rate in response to measured traffic conditions, maybe measuring the back of the queue relative to not blocking the arterial and those kinds of issues. Incident management, if you had to pick probably one thing to do that would best address the non-recurring congestion problem, incident management would certainly be at the top of the list. And all the elements of incident management come into play. It's the detection of the incident. It's getting the incident cleared as quickly as you can. It's setting up the procedures so that everybody knows what their rules are and how they're supposed to cooperate and what they're supposed to do. It's getting traveler information out to the public so they know about the incident and can make their travel decisions based on that information. And it's doing what you can do in terms of better managing the traffic loads when there is an incident, both on the freeways or on the parallel arterial streets. So a very important strategy. Traveler information goes along with that. Traveler information, again, becomes increasingly important. It's important all the time, but it becomes increasingly important when there are these unexpected conditions or bad weather conditions or special events that pop up. What we've seen in traveler information, you've no doubt heard or experienced or maybe even manage some of the public 511 systems and websites and so forth. But I think we know that increasingly traveler information is provided as a service. We're getting it inside our vehicles from a variety of different providers, and that market, that traveler information market, has just exploded since the early days of ITS, and it's good, helping a lot of people. We're seeing more emphasis on lane and speed control, something that has been used in Europe for much longer, actually, than it has been used in the U.S. And the idea is, we talked earlier about the relationship between congestion and safety. Well, the issue behind lane and speed control is really to do both, and it's to prevent those secondary accidents, the high-speed vehicle that abruptly comes on the back of a queue from an incident that's further downstream, preventing those secondary accidents and how that contributes to increasing congestion. So slowing vehicles down before they come to the scene, or suggesting or demanding that they shift lanes to avoid a work zone or an incident that's further downstream. We'll talk a little bit later about something called active traffic management, which incorporates a lot of the principles that we talk about with lane and speed control. We're doing a lot. Probably the most early success story with ITS was electronic toll collection. It's saving toll agencies cost. It's saving motorists a lot of delay sitting in queues, waiting to pay tolls. It's been a real success story. But it's even broader. We see transit, people now paying transit fares through passes or through credit cards. So not fumbling around needing to come up with exact change to use a transit system, or waiting for the driver to make change and those kinds of things. We're seeing parking payment systems. We're even seeing tolling applied to high occupancy vehicle lanes, essentially providing an opportunity for people to buy into the use of those lanes. Places like Seattle, Minneapolis, Washington, D.C. are using those what are called high occupancy toll lanes or hot lane type systems. So we're doing a lot with electronic payments. Commercial vehicle operations was another early success story, especially as it relates to weighing of vehicles, automated weighing of vehicles, providing clearance, electronic clearance for vehicles and drivers that have all their paperwork and orders. We're seeing some emphasis more recently on things like truck parking, advising truckers as they reach the limit of their hours of operation where parking is available. That's been a real safety problem as truckers have pulled off onto shoulders and other not so safe places to rest for the night. So that has implications beyond just the convenience for the drivers themselves. Freight management in areas where there's ports, being able to, on demand, send a drayage vehicle in to pick up a load is another application that's become very important. Transit is certainly accounted for within the menu of strategies that are available. We've talked a little bit about some signal priority kind of things. Many agencies are doing an excellent job now of informing passengers of arrival information, when they can expect the next bus or the next transit vehicle, and that's helping them do a better job of scheduling. All that data that comes in helps them do a better job of scheduling so that things can remain even better and more responsive. We're seeing things now, I talked about, mentioned that we were going to talk about active traffic management. These are things that combine a lot of the things that the previous strategies that we've just talked about into a broader kind of a system. So let's just deal with the integrated corridor management aspect because it accomplishes a lot of what I just said. The integrated corridor management, as the name implies, deals with looking at a corridor as opposed to an individual facility. So it's the freeway, it's the arterial, it's the streets that connect the freeways and the arterials. All of that is looked at as a whole. So you're looking at the freeway, typical freeway management kind of things, the incident management, the variable message signs, the surveillance cameras, all those kinds of things that comprise freeway management. You're looking at the arterial management, and that not only includes the signals, but that may also include surveillance and variable message signs and those kinds of things along the arterial. You're looking at lane and speed control for the reasons that we talked about earlier. You're even looking at public transportation and looking at potentially signal priority or other ways of improving bus rapid transit, perhaps other ways of improving public transportation service within a corridor. So in short, it's a holistic way of looking at managing a corridor, better managing a corridor, and thinking about how all these ITS things in our bags of tricks, how all that can work together to achieve that. And there's more. We can go on for a while. Just want to mention maybe a couple of things. One of the more recent advances that we've seen is this notion of ride sharing, and through not only through public systems, but also through very successful private operations such as Uber and Lyft, which is transforming, using technology basically to transform, especially in urban areas, transform the transportation system. And we haven't even mentioned yet connected vehicles, and that's a whole another subject that we could go on and on about. But connected vehicles essentially are about automating the driving task and looking at not only automating the operation of vehicles on a facility, but interacting with the infrastructure so that we achieve better performance and safety. That's coming. We can debate when, we can debate in what form, but it is coming, and it holds promise for making a huge transformation in how we deal with transportation management. So let's talk a little bit about the evolution of TSM&O. The ideas, as I probably said a number of times already, the ideas behind TSM&O aren't necessarily new. The concepts aren't necessarily new. I started my career as a young researcher in the Federal Highway Administration back in 1977. And when I was there, we were working on projects called ERGS and IMIS. ERGS was the Electronic Route Guidance System. IMIS was the Integrated Motorist Information System. So we were thinking about in-vehicle information back in the late 70s. We were thinking about integrated corridor management back in the late 70s. So a lot of these concepts aren't new. What is new is a few things. Number one, the problem has just gotten worse. We saw the diagram with the two differently sloped lines, so the demand increasing much greater at a much greater rate than the supply. The congestion problem has gotten worse. The second thing that's happened is that the technology has improved immensely. What we were able to do from a technical standpoint, even just the computers that we had available back in the 70s, pales in comparison to what we're able to do on a microchip today. So that's completely different. And the third thing that's different is that the traditional solutions that were widely used in the 70s still largely dealt with providing additional capacity, new facilities, building new roads, widening, and so forth. We were into that mentality. And that mentality has now emerged, and so has the look now at the role of TSM&O within an organization. So let's talk about that a little bit. Now, this slide tends to be perhaps a little negative, but there's truth to it. What we did in the 70s, well, we did ramp metering, we did traffic signal timing. We were looking at lane management. You could see lanes with red X's above them, and you can go down. And what are we doing today? Well, we're still doing all those things, but as I said, they're more widely deployed. We're doing them better because of the advantages that we have. We've had some success stories. We've talked about some of those already. We've talked about the expansion of electronic payment systems, not only tolls, but looking at things like hot lanes, and even in some cases, at least considering the notion of a broader area, congestion pricing kind of a system. This says 511. I would broaden that, just the whole general subject of travel information and the improvements, even to the point where in a major urban area such as Washington, D.C., when I lived there, you could get a traffic report every 10 minutes. And so you were pretty well up to date, just traditionally, through a very traditional means of getting that travel information. So we're getting it inside our vehicles, we're getting it via websites, we're getting it improved information through the radio. There's all sorts of ways that we're getting better travel information than we were 5, 10, 20 years ago. And we're doing a better job of making people aware. We're not only posting travel times on VMS, we can see congestion maps. We have routing algorithms inside our cars that account for current congestion. Transit riders are getting passenger arrival times at bus stops and subway stations and the like. So we're doing a good job there. And even into areas like photo enforcement, especially in areas like school zones and other problematic safety areas. But as we know, congestion continues to increase, and the money hasn't necessarily kept pace with the advances of what we're able to do. Again, in large part because the pie available to support all transportation hasn't grown in a long time in most cases either. So what can we do to further the cause, if you will, of doing a better job of transportation system management and operations? Well, this slide suggests a few things, and we'll go down through most of these one by one. The first thing is to just, as we started, is to focus on improving performance. And there's a lot of different ways to do that. This slide suggests a few ways of doing that. Focusing on keeping our signal timing as responsive as we can to current conditions, perhaps through the use of adaptive type control systems. We can do a better job of managing incidents, a lot of focus, rightfully, on the subject of quick clearance and getting incidents off the road so that normal operations can be restored. But we can do a better job of informing people about incidents while they're out there. We can do a better job of load balancing during those incidents and better managing traffic when we do that load reshuffling, if you will. We can do a better job of considering the role of public transportation and the relationship between what we do typically as highway operators versus what we can achieve by focusing and applying public transportation strategies. And just considering in a broad sense the TSM&O and the ubiquitous use of TSM&O throughout urban areas or states or whatever our area of responsibility is. Another area where we can improve is the notion of outreach and marketing. Mentioned those workshops that we've been doing across the country. That again is something that pops at almost every workshop, is we haven't done a real good job of telling our story. And I say we as the broad we, the TSM&O community, if you will. We tend to talk to each other in acronyms. We tend to tell each other a pretty good story, but we don't necessarily get the word out throughout our organizations, up the chain, into the legislature, into the public in general about what we're doing and the benefits we're achieving. It's not necessarily an easy story to tell, but well worth the effort to look at publicizing TSM&O, not only through our own professional organizations, but probably more importantly to our publics, however that is defined. Focusing on customer service, as I said earlier, is a very important one. There are people doing a very good job of doing things like customer surveys. A number of areas have instituted freeway service patrols, which are always very popularly received, and there are stories of letters that come in complimenting agencies on the service, so that's always an excellent public service. When we do traveler information, when we're providing good traveler information to people, that's a customer service and ought to be considered and dealt with that way, whether that be through 511 systems or websites or however you're doing it. So all those elements comprise the notion of doing customer service. But one of the things to think about is that we tend to think of our customer, and I think we tend a lot of times to automatically lapse into the idea that our customer is the commuter. And that's one of our customers, and that's an important customer, but there's a lot of other customers out there as well. There are people on vacation, there are people in the freight community, truckers and shippers, there are businesses, there are property owners. All of those are customers in some aspect, in some different way. And as this chart suggests, as we think about those different customers, they all have a variety of different concerns. There's always, as this slide would indicate, there's always different ways of reaching those various customers. So it's important, but it also requires some thinking beyond just the typical notion of thinking about commuters and how we can improve the commute trip, into thinking about different types of customers and different ways of reaching them. Probably the important point in this last slide dealing with this subject is that middle bullet, that it's not a single person's responsibility. It's not the responsibility of just the public information officer. It's the responsibility of everybody in the organization. You're there for a reason. You're providing public service, and everybody ought to have that orientation of providing good customer service. This project, Sharp LO1, deals not only with the subject of customer service, though it does deal with that, but this is the research project that actually produced the series of workshops that I referred to earlier. So it does a few things. Number one is it was a research project that looked at TSM&O programs around the country, and essentially posed the question, why are some people reporting results that are better than other people? And so it asked that question, did some surveys, and concluded that the reason that some are better than others didn't have anything to do with the technology or those kinds of things, but had everything to do with all these processes that support TSM&O as a program. So it was what agencies have processes in place to plan for TSM&O. What supporting processes are in place from a procurement maintenance perspective to support decisions about technology and systems. Is there a performance orientation? Is there a lot of good record of collaboration both internally and externally? And all those kinds of issues. That was put into a framework. It was put into a model that can be done as a self-assessment through the National Operations Center of Excellence. You can find all that information, do your own self-assessment for your agency, and there's still workshops, facilitated workshops that are available to deal with those issues and self-assess where you are related to a lot of these things. And this basically just illustrates what I just said, that the answer lies in that supporting institutional framework that produce the processes that support TSM&O as a program and deal with TSM&O as a competitive program. Another Sharp 2 project that deals with aspects of that is this Sharp 2 LO5 project. You can see the title, Incorporating Reliability into the Transportation Planning and Programming Process. And it's a research result that basically looks at this notion of how you deal with TSM&O kinds of strategies or improvements, and how you deal with that as part of a planning process that's traditionally been more focused on capital project investments, larger investments, if you will, than what we typically look at as TSM&O. Again, worth looking at. So let's begin to wrap this up. Let's look at looking at the benefits of TSM&O. I think we all know that there are many positive attributes. You can look at it in terms of improving congestion across the board, both looking at it from a recurring perspective, but probably more importantly looking at the non-recurring aspect of it. There are strategies that most of them address supply, but some of them also address demand, trying to either reduce demand during periods of incidents or perhaps get more people involved in using public transportation and reducing the vehicle demand. There are arterial and freeway strategies. There's probably relatively little impact on travel behavior. One of the things that always come up when you talk about building a new facility or adding capacity to a facility is this notion of induced travel demand and whether building that facility is a good or a bad thing, because ultimately it too will become congestion at some point. You really don't deal with those kinds of things when you're dealing with TSM&O. Some people may argue that there's some minute impacts, but very little and very difficult to get a handle on. TSM&O can be implemented much more rapidly than major construction projects, and they can be done at a relatively low cost. So lots of good things. This chart illustrates some of the benefits that have been reported. A lot of this obviously depends on the preconditions and what was measured and how it was measured, but but very positive benefits throughout the literature. This chart basically contrasts operations and construction, looking at it from a number of different perspectives. Benefit cost ratios, you see the ratios for operations projects, reported ratios tend to be larger. Now that masks a little bit of that the B's and the C's associated with construction tend to be bigger than the B's and C's associated with the operations, but nevertheless from an investment, from a effectiveness standpoint, the ratios on the operations side tend to be higher. We talked about the impacts potentially being widespread throughout a corridor or a region for TSM&O. We talked a little bit about the rapid implementation relative to major capital improvement projects, the little, if any, impact on affecting travel behavior or induced demand. On the other side, when we talk about TSM&O, typically we talk about small benefits that are accruing to lots and lots of travelers. So it becomes hard to perceive, whereas there's no missing when you're opening up a new facility or opening up a new lane on a bridge or as part of a facility. So the construction side becomes more highly visible, and because of that, a lot of times becomes more politically attractive. It's a better picture when you're cutting a ribbon on a new highway than if you're cutting a ribbon in front of a building with a bunch of computers and a screen that the operators are looking at. So if we look at this notion of whether we should do TSM&O or new capacity, I think the answer probably lies in, it's not probably even a fair question to pose it in that way, because the answer is you need to do both. I have always said that the role of TSM&O is not to be looked at as an alternative to new capacity or new construction, but the role of TSM&O is to manage whatever capacity is out there and manage it as effectively as you can. So if you need a certain amount to deal with the recurring congestion problem, you still need TSM&O to operate whatever capacity is out there and operate it in an effective way. And so again, it's not or, it's both. This next slide presents as a decision tree, and again, I think the important, and we've probably beaten this to death at this point, but the notion of is looking at the recurrent in the left box, the non-recurrent in the right box, and seeing that in the left box there are more traditional kinds of measures that you would typically be led to, whereas in the right box there are more TSM&O oriented measures that you would typically be led to. So what's the overall message? Well, the overall message is that we start by saying TSM&O is not a panacea. I might start it a little bit differently. It's very important. It's certainly not a panacea. It's not going to solve every problem, but it is important to do it and to do it in a programmatic way. It could be considered as an alternative, but I think more important, it's a way of dealing with managing whatever capacity is out there, especially dealing with the non-recurrent problem. We've talked about the notion of implementing solutions more rapidly at lower cost. So with all these good things, why are we at this point in time where we're looking at, if you will, the teenage years of TSM&O. We're looking at resources that are available to support it, and maybe thinking that those resources are inadequate. Well, we're still fighting the traditional DOTs and ways of looking at problems and thinking about building as the solution that automatically comes to mind. The greater visibility of new facilities is certainly a political consideration. We have a lot of inertia to overcome in terms of the people that make their living off of doing new construction. And in fairness to all of that, we have an infrastructure that is deteriorating. You can look at some of the information and data coming through the ASCE, the American Society of Civil Engineers, and know that, that we have problems just with the physical infrastructure itself. So all that is probably a way of making the point that we made earlier, that really, if we want to look at TSM&O and look at increasing resources for TSM&O, it really is a problem of making the whole pie bigger, not necessarily fighting for resources of a stable or, in some cases, even a shrinking pie. LO7, another SHARP 2 research project. This one deals with the subject that we've just talked about. This looks at basically highway design features and looks at a number of design treatments that could be built into projects that would help with managing the non-recurrent congestion problem. So, for example, it might be an accident investigation site that gets built into a facility and those kinds of things that get discussed. So we're going to just go through, to wrap this up, we're just going to go through, some of this is a repeat, but we're just going to go through some of the SHARP 2 things that we've talked about. I would remind you that all these tools are at least referred to on the National Operations Center of Excellence site, so I would go there. I think probably the important point of this slide is that the tools mentioned in that second bullet, the 2, 4, 5, 7, and 8 reports that we talked about earlier, are being looked at, pilot tested, if you will, through a project that was designated as L38. And so essentially what we have are some volunteer state DOTs that are looking at actually applying the reports that came out of this research. There'll likely be some adjustments made to the research reports themselves as a result of these pilot applications. So that gives you an idea of where these things stand. They're developed, the research is complete, but still being looked at in a pilot sense and by people like yourselves that are trying to apply these things. This slide I won't go through, but that basically lists the 5 research reports that are being looked at through the L38 pilot test. You can see the name and the product that the pilot testing agencies are applying. And this is another way of looking at it that illustrates the research reports, what type of facility they're applicable to, applicability from the standpoint of the phase, whether it's planning, design, operations, and the type of agencies that may be users of this information, be it a state, a planning, a typical MPO planning agency, or a municipal agency of some sort. We mentioned some other things that aren't part of the L38, but bear as a reminder. One of these is the LO1 report, which we talked about in terms of leading to these workshops and the business, the focus on the business process and so forth. The LO4 report, which looks at incorporating reliability measures into the planning process so that TSM&O can be dealt with more fairly, if you will, within the planning process. And there may be other things that have emerged from the SHARP 2 program, not only in the reliability aspect of the program, but in some of the other aspects as well that may be of interest. So last slide. This is our call to action. I think what we have tried to do through this overview of operations course is to impress the importance of TSM&O, impress the importance of thinking about it as a program, and all the things that go with a program, the planning, the established processes, the identification of resources to support programs, the performance management aspect, thinking about your organizational issues, your workforce issues, your relationships, both internal and external, and all of that comprising a new culture if you will, of your organization that treats the operation of the facilities as importantly as the construction of those facilities in the first place. So thank you for your attention and good luck.